and welcome. And in this video, we're going to solve absolute value inequalities, okay? Now, if you haven't watched my video on solving absolute value equations, make sure you go ahead and double check that. That's where I kind of go step by step and break everything down. I'll put a link in the description below, but make sure you check that out if you didn't already. So solving absolute value inequalities is actually very similar to solving absolute equations, okay? So I have two real basics examples, and I'm still thinking about in terms of the number line, okay? So I'm going to start with this one over here. Well, remember, what absolute value measures is a distance. So this is kind of asking, okay, what number or numbers are less than or equal to 3 away from 0 on a number line? That might be weird to think about. So why don't we just plug in some numbers? So like, for example, if I plugged in 0, if I said x was 1, that would be the absolute value of 1 less than or equal to 3. The absolute value of 1 is 1. And is 1 less than or equal to 3? Yeah, it is. So that would be a solution. What if I plugged in 2? Is the absolute value of 2 less than or equal to 3? Yeah. What about negative 2? About negative 1/2? What about positive 3 and negative 3? Yeah, they would work. If I plugged in positive 3, the absolute value of positive 3, I wanted to see if that's less than or equal to 3. I'll get 3 less than or equal to 3, and because it's or equal to, that technically works. So all of these numbers in between negative 3 and 3 actually work. And what we're actually seeing here is a compound inequality, okay? Because we're actually going to have all these numbers in between negative 3, positive 3. So all those numbers in here in this shaded region here, all these numbers in the shaded region here, those are all solutions. Okay, and notice how for this it's shaded inside. It's all those numbers. So it's actually an infinite number of solutions because there's an infinite number of numbers just in between negative 1 and 0. Okay, so it's going to be an infinite number of solutions, but they have to be greater than or equal to negative 3 and also less than or equal to positive 3. Okay, so that's what we call an and compound inequality. Okay, that's what we call an and compound inequality. Whenever it's shaded inside, it's an and compound inequality. And the way we can write that is kind of neat, actually. Well, we said x had to be greater than or equal to negative 3. So x is greater than or equal to negative 3. But it also had to be less than or equal to positive 3. So that would end up being our solution. Negative 3 is less than or equal to x, which is less than or equal to 3. Basically, it's all the numbers trapped inside. We are trapped inside here, okay? And I'm showing that 3 and negative 3 are included by plotting these kind of solid dots, these solid circles on the number line. That's showing that our answer actually could be 3 or negative 3. It's all the numbers in between, okay? But what about this one over here? X, the absolute value of x is greater than 3. Not or equal to, just greater than. Okay, well, we can once again just plug in numbers. If I plugged in 4, absolute value 4 is greater than 3. Well, that gets me 4 is greater than 3. That checks out. So that would be a solution. 5 would also be a solution. If I plugged in like negative 10, the absolute value of negative 10 greater than 3. The absolute value of 10 is 10. So that works out. So negative 10 would be a solution. Actually, all the numbers greater than 3 and also all the numbers less than negative 3 are going to be solutions. So I can show that on a graph by using an open circle on positive 3 and kind of just shading all the numbers to the right. So I'm just going to kind of use an arrow to show that. And then also using an open circle on negative 3 and showing all the numbers to the left. Okay, and notice that this is shaded. Pardon my terrible hand. I don't even know what I'm writing. This is shaded outside. This is what we call an or compound inequality, okay? And the way we would write this answer is, well, x could be less than negative 3, or x can be greater than positive 3. So there's two kind of separate ones, and this is also a compound inequality. Notice how I wasn't able to write it as like one big giant connected one. You can only do those with compound inequalities, okay? And that's kind of how we start solving absolute value inequalities, all right? Whenever we isolate the absolute value, notice it was isolated as by itself. That's step one. That's still step one. Once the absolute value is isolated, if that inequality symbol is less than or equal to, it's always going to be an and compound inequality, and it's always going to be shaded inside like this, okay? However, if you isolate the absolute value inequality and it's greater than or equal to, it's going to always be an or compound inequality. I know this might sound a little bit confusing at the moment, but let's go ahead and actually go through some problems and look at how this is done. So we have an example here. We have the absolute value of 2x plus 7 minus 4 is less than 1. Okay. Now, just with equations, the same exact way, we want to isolate the absolute value first. So I need to move this minus 4 over. And to do that, I need to add 4 to each side. So I'm going to add 4 to each side. I'm going to get the absolute value of 2x plus 7 is now less than 5. Okay. So step one is the same, isolate the absolute value. Now, step two, the exact same way with equations, we had to set up two equations. In this case, we have to set up two inequalities, okay? But we need to determine what type of inequalities. And compound inequality, where all the numbers are trapped inside, or is it going to be an or compound inequality, where all the values are kind of going in opposite directions, kind of running away from each other, okay? Now, you can only determine that once it is isolated. Do not judge it based off the original problem, only once the absolute value is isolated. So if it already is, then you can, but make sure it's isolated first. And in this problem, it is isolated now, and it's less than, and what that means is that it's going to be an and compound inequality. The less than means it's going to be an and compound inequality. Okay, and with and compound inequalities, you can actually set up the inequality in a nice way, that kind of nice way that it was written as one big one. We can do the same thing. Okay, now the inside never changes. I'm going to kind of write it up here. The inside never changes, so 2x plus 7. Now that is going to be less than 5, and it has to be greater than negative 5. Now, since it's an and, I can actually write that greater than like so, okay? Because this is still written as, you can still kind of read this as 2x plus 7 is greater than negative 5, but also and less than positive 5, okay? And now we can solve this, okay? And I know it looks like there's an extra side, because it kind of is, but we still solve this the exact same way. We would solve for x by first subtracting 7 from both sides. Well, not both sides, now kind of all sides, because there's more than one, okay? So I would subtract 7 first, and this would become negative 12 less than x less than negative 2. And now if I was just solving a normal inequality or equation, I would divide each side by 2, and I still divide each side by 2. So this is going to become negative 6 less than x, which is less than. So there is our solution as an inequality, compound inequality. I do want it to also be in a graph, though, so I got a little number line here. So we can go ahead and plot that on the number line. So now notice it's trapped in between negative 6 and negative 1, and it's not or equal to. Not or equal to. So I show that with an open circle. So an open circle on negative 6 and negative 1. And notice x is trapped in between. It's trapped in between negative 6 and negative 1. It has to be greater than negative 6 and also less than negative 1. So I'm shading all of the values side, okay? And that would be our solution on a number line. But I do want to cover one more way that we can write our solutions. And this is the way in higher level mathematics that you're going to want to write a lot of solutions. It's something called interval notation. And some of you might have some experience with this already. If not, it's totally fine. It's really not that difficult. Okay, interval notation is just another way of writing all the solutions. It's gonna kind of look like a coordinate, like a point or a set of points. Okay, now the way we do interval notation is we think about all the values that x can be from smallest to greatest. Okay, read it from left to right. I realize that I'm not mirrored. Okay, or that I am mirrored. So I'm going to read this from left to right. All the numbers from smallest to greatest. Well, the absolute smallest number that x can be is negative 6, but not included. Notice that's not included. It's an open circle. So since we can't be negative 6, but it starts like right after it, I'm going to show that with a parenthesis, okay? Now, if that was a closed circle, if it was or equal to negative 6, I would actually use a bracket, okay? And we'll take a look at that in the next problem. But since I can't be negative 6, I use a parenthesis around. I'm saying, hey, we start at negative 6, and I go all the way to the largest number x can be, which is negative 1. And notice I once again also cannot be negative, so I use a parenthesis as well. So this is a solution in inequality notation. This is a solution in interval notation. And moving forward, it wouldn't be a bad idea to start focusing on it. And it might be difficult to get the answer before graphing it. Feel free to graph your solutions. It only takes a second or two. And it does help with interval notation. Now I can literally see, okay, well, I start at negative 6 and I go all the way to negative 1. But you will get comfortable enough where you don't need to graph on a number. Okay, but let's take a look at one more problem. Okay, so we got another example here. We have 3 times the absolute value of x minus 4 plus 6 is greater than or equal to 12. Okay, first step is to always isolate the absolute value. So that's what I'm going to do. So I'm going to start that by subtracting 6 from each side. Okay, and what I'm going to get there is 3 times the absolute value of x minus 4. 6 is cancel. Okay, is greater than or equal to 6. Okay, now I'm still not isolated. Need to isolate. Remember, you don't want to distribute that 3 into the absolute value. That 3 is multiplying the absolute value, so I'm going to undo that by dividing. This is where I should put a little disclaimer. Remember, with inequalities, if you ever multiply or divide by a negative number, you're going to need to flip the inequality symbol. So let's say this was a negative 3 and I was divided by negative 3. This would now become less than or equal to, okay? But it's a positive number in this case, so it stays the same. So we're going to have the absolute value of x minus 4 is greater than or equal to 2, okay? And now we have it isolated. Now we need to determine what type of compound inequality it is. We have the absolute value isolated now, okay? And it's greater than or equal to. Well, whenever it's greater than or equal to, it's going to be an or compound inequality, okay? And the way that we set this up, we're not going to be able to set up as like one big nice one. You have to set it up as 2 separate inequalities, just like we had to set up 2 separate equations in solving equations video. So the first one stays the same, x minus 4 greater than or equal to 2, or x minus 4, flip the symbol, less than or equal to, flip the sign, negative 2. Okay, so notice I had to flip the symbol and flip the sign, so it became negative. All right, and now I'm going to solve each of these. All right, so that's step 3, solve your inequalities now. So to do that, I'm going to add 4 to each side. And once again, you can solve these separately. You don't have to do it at the exact same time, but for time purposes, I'm going. So this is going to become x greater than or equal to 6, or x less than or equal to 2. Okay, and those are my 2 solutions. Okay, now this would be written as an inequality. Now I do want to also be able to graph it on a number line. Now we can be greater than or equal to 6. So I'm going to say this is 6. And notice it's or equal to, so I'm using a closed circle. Okay, and I can also be less than or equal to 2. And since it's or equal to, that's also going to be a closed circle. Now, x greater than or equal to 6, that's when like x is 7, 8, 10, 1,000. That's to the right, so I'm going to shade all to the right. Okay, so I'm just going to use kind of an arrow. So that's me shading all to the right. So all the numbers greater than 6, or the numbers could be less than or equal to positive 2. So that would be on a number line. Now, I do also want to talk about interval notation here, and this is where it can get a little bit trickier, okay? We still list all the solutions from smallest to greatest. It's just that it's 2 separate parts now. So I'm going to have actually 2 separate intervals. Now notice that it's going all the way to the left. So it's actually going all the way to negative infinity. So the smallest number x can be is negative infinity. And you can never actually touch an infinity, so you never put brackets on infinity, okay? Always going to be parentheses. So notice the smallest number x can be is negative infinity, and that's because my solutions are going all the way to the left. okay? And they start at negative infinity, they go all the way up to 2. So it stops at 2. And notice it's or equal to, it's solid, so I'm going to use a bracket. Brackets are used when it is or equal. But then I stop. It's an or, and in interval notation, or is represented by this like big fancy U. Stands for union, okay? It just means or in math ways. So or, that's what that big U for union stands for, or. And then we don't start up again until 6. And we can be 6 because it's or equal to. And notice it goes all the way to the right to positive infinity, and we can never be infinity. So this would be your answer in interval notation. And make sure you don't have these switched up. This interval needs to come first. This interval needs to come second, because we always read graphs from left to right. I go from negative infinity to 2, stop, start at 6 to positive infinity. Just like that, okay? And that is solving absolute value inequalities. I will record another video because these ones tend to be a little bit trickier. So I will have another video that are just a couple extra problems, a little bit more complicated, maybe some special cases, okay? I hope this video helped you. If you have any questions, please feel free to let me know. Next video will be some more examples, but after that, we're going to get into graphing.